Good morning, George. Today's lessons will be on equivalent fractions. Have you heard of that before?
Do you mean fractions that are the same or nearly the same?
Yes, George, that is what I mean. The equivalent fractions will represent the same size, although they will look different.
Do you mean like a half and two quarters?
That's exactly what I mean, George. Sometimes when we are adding or subtracting fractions, we might want to think of half as 2/4, so it is useful to know what it's equivalent to.
I've just thought of another example where the numbers are different but the size is the same.
Okay, George, see if you can impress me.
Well, 1 hour is the equivalent to 60 minutes,
Well done, George, you are on the ball today.
and 1 minute is equivalent to 60 seconds. And
Okay, George, we know you've got it. Think we've spent enough time on that, so we'd better start the lesson now. So in this lesson, we're going to be looking at situations where we have to be able to change a fraction, but without changing its actual size. And when we do that, we say that we've got an equivalent fraction. So what do we mean by an equivalent fraction? Well, we mean a fraction which represents the same size or portion of a whole object. Now, don't forget a fraction has two numbers separated by a line, so when we write the fraction a half, what we're actually saying is that we're dividing our object, which in this case is a rectangle, and we're dividing it into two pieces. The bottom number tells us the total number of pieces our object is being divided into. The top number is telling us how many of those pieces we are choosing. So in this case, I've coloured green the number of pieces I'm choosing, so this fraction represents 1/2. Now let's look at the rectangle below. This rectangle is the same size but has been divided into 4 pieces. And what I'm going to do is I'm going to colour in 2 of those pieces. So the fraction that I'm going to colour in is going to represent 2/4. And as you can see, the blue part of the rectangle and the green part of the rectangle are exactly the same size. So they must represent the same fraction. So 1/2 or a half and 2/4 must be equivalent fractions. Now let's look at the third rectangle. It's again exactly the same size as the other two, but this time it's been divided into 8 pieces. And what I'm going to do is I'm going to colour 4 of those pieces, so the fraction coloured will represent 4/8. And as you can see, the third one is exactly the same size as the second one, which is exactly the same size as the first one. So all the coloured parts represent the same proportion, they all represent the same fraction. So 4/8 is equivalent to 2/4, which is equivalent to a half. And so one more example to reinforce the point. This time we've divided the bar into 10 pieces, and I have selected 4 of those and coloured them blue, so that blue portion is represented by the fraction 4/10. So I'm now going to colour in the same size of piece in the bottom one. This time we'll make it green, and so the bottom coloured part is exactly the same size as the blue one, and therefore the fraction at the top must be equivalent to the fraction at the bottom. The fraction at the bottom is going to be, in this case, 2 pieces out of 5 in total, and so 2/5 will be equivalent to 4/10. Right, so let's now look at those results and see if we can work out arithmetically how to change a fraction to an equivalent one. Well, the first result was 1/2 or a half, and it was equal to 2/4. So what we can do is we can multiply the top number by 2 and we can multiply the bottom number by 2, and that will give us the equivalent fraction. When we're changing from 2 over 4 to 4 over 8, we will do exactly the same thing. If we multiply the top number by 2 and multiply the bottom number by 2, then we will have the fraction 4 over 8. If we look at the bottom fraction, then we're doing exactly the same thing. In order to make the 2 into 4, we will double it, and in order to make the 5 into 10, we will double it. Of course, we don't have to multiply the top and bottom of the fraction by 2. We could multiply the top and bottom by 3 or 4 or 5, as long as we do it by the same number. So in this example, I'm going to multiply the top and bottom number by 3. So starting with the fraction 3 over 5, I'm going to end up with the answer 9 over 15. Of course, we can work in the opposite direction. We can take a fraction and make it smaller, as long as we can find the same number that will divide into both the top and bottom. So let's look at the example 15 over 25. Now the number 5 will go into both 15 and 25. So if we divide the 15 by 5, that will give us 3 on the top. And if we divide the 25 by 5, that will give us 5 on the bottom. So the fraction 15 over 25 is equivalent to or equal to 3 over 5. Okay, so this is the point at which I would ask you, the audience, to try these problems for yourself to see how well you've understood the work that I've explained so far. So in these problems, it's fairly self-explanatory, but if I can just point out one or two things. What you're trying to do in the first one is to find the number where the question marks are, and obviously all three of these fractions are equivalent to each other. In the bottom one, you're trying to find the number for the top and bottom. What you're trying to do is to simplify the fraction, and that means that you want to make the top and bottom numbers as small as possible. Right, so what I would suggest you do now is to press the pause button on your video, try these for yourself, and then I'm going to ask George also to show me what he got in the way of answers, and you can then compare yours and see whether you've got them right. Okay, George, would you like to tell us what you did in these problems?
Well, the 8 has changed to a 2, so it must have been divided by 4. So if I divide the 12 by 4 as well, that will give me 3. And for the second one, the 3 has been changed to 30, so it must have been multiplied by 10. So if I multiply the top by 10, that gives me 20. For the last one, I need to find a number that gives me into both 45 and 60. 5 goes into both and 45, divided by 5 is 9. And 60 is divided by 5 is 12.
Do you think, George, we could divide something else into 9 and 12 to make them even smaller?
Oh yes, I didn't notice that. I could divide them by both by 3, so that makes it 3 over 4.
Yes, George, that is correct, and that is the final answer, 3/4. I hope you at home also got the correct answers. If not, then just go back over the previous examples that we've tried and try to understand it better. So that's the end of the lesson. Thank you for joining us today. So it's goodbye from me.
And it's goodbye from me.